Okay, so let's summarize what we've been talking about. So the single linked list is a type of structure that will allow us to have some kind of a shortcomings of an array. That, you know, the array, if I'd like to insert in the middle, for example, I would like to insert to the beginning or to the end. It involves some work that is not really efficient. Now, these linked lists are, I mean, there are two types of those. The singly linked list means there's only one link one way that's going to be having to represent every element. Every object has like two things: the information, that's what this is referred to, the information, and then the next element that is going to be the next element in the list. Now, I don't want to. I think you've seen this. You know what this means? Generics. What are generics? I'm sorry? A class that have a data type that can change. So now this, for example, now this class is called SLL node, singly linked list node. Will take, depending on the data type that we're going to give it to, this data type is going to be the info. But I can have a simple implementation of that without using the generics, but this makes sense. Let me just start a new project, and then let's go at week 1 in CS single linked list. Okay, so let's keep this here. I'm going to create a new class. By the way, I'm going to use NetBeans. I don't know what you have used before. Probably you might have used something different on Java too, but I'm going to use NetBeans because it helps a lot. So this is going to be my node. The node of singly linked list node, or let's just keep it the same name, is a class. This class, let's say it has two things: the value or the info and the link. But what is the link? What's the data type? It's the same data type of the class itself. That's the link, which is the next one. Of course, I'm going to make those to be private, but for now, I don't want to make them available, so I don't have to deal with those. Now, this is my list. Now, if I'd like to create a new node, what should I do? Well, first of all, I should have something that is going to be referring to this list. So, how to call it? So, in the main, what should I have? Let me declare new node that's going to be a list, or now how can I have the list here of nodes? It's going to be an array of lists of nodes. How can I have many nodes? I'd like to have many nodes like this. Here, like this. So in order for me to do something like this, I mean, the node is this one. So if I declare something like this, this is going to be just one node, equal new list, no, new SLL node. Now this list has two, either the information and then what's next. So this is just not the list, this is just one of the nodes. So the info, for example, I can just put like the info to be the 10, and then dot next is going to be null because there's nothing for now. But what if I would like to have more of these and link them together? What should I do? I mean, this is probably what you're referring to be the previous anyways. Now what should I do? The new one. Let's say now I added this one, right? Now I'd like to add this 8 here. So I create a new object, which is SLL node. What am I going to call it? N2 equal new single linked list. Okay, that's going to take too much time before it gives up. Okay, then the N2 dot info is going to be 8, and the N2 dot next is going to be null. Oh, first of all, we created this. Sorry, hold on. Let's maybe go back to the previous slide where it has this. Yeah. So first of all, I created this. Sorry, why is it doing this anyway? This is this line, right? Then I put the 8. This is this line. Then I put the null. So this is this line. Now we should do this. Now we should do the connection before deleting, not delete anything. Let's just do the connection. How to connect them? So the first one, this list that I called list, dot next should be equal to what? 8? This is int. How can you put an int into an SSL node? So we need to put a type SSL node, which is N2, and N2 has the information. In the information it has 8. Now this list now is pointing, the first element of the list is 10, and then if I click next it's going to give me the 8. But how can I do something? How can I work with it? It's still not clear that what this time it's a list, this other time is. I'm going to remove this. I'm rename it. Instead of list, I'm going to call it head, because it will make more sense, because this is where the head is. The first one is the head, and then I put the information to be this new node that I have. Now what I can do something like this. For example, the head is like this, and I create now a new node that I call N1. And let me just show you what I would like to do. And I do this something like this, and then after doing something like this, I put the head to be N1. Maybe that's something that is going to be a little bit closer to what this is represented. So this P here, basically this is the head. So this head is like a node, but it's a node that is exactly the same as this first node. Now this first node has this, and then I put this first node to be the head, which is now, if I use head.info, if I display something like this, this time, before doing anything, if I display head.info, what should I see?
10.
I see 10. I will see 10, inshallah. Yes. Now if I'd like to display the next info, now for example, if I do something, now I added this new node N2, and this node N2 was the next one after the head. Now if I'd like to display now the 8, what should I do? I can put N2.info, right? This is going to show me the 8. But if I don't want to use this N2 and use only from the head, can I? How? From the head, I need to go to the next, and then the info. So that's why I can see here next.info. So hold on. This dot next is going to be what? This, the head dot next is going to be this thing. Dot info, because this thing is a node. This node has info and it has next. That's why if I use dot after the next, because the next one is a node, it has an info and it has a next. If I use the next info from the head, go to the next info, it's going to give me the information from the second node. If I run this thing, I'm going to see 8. And you see now this is the linked list, because I can get one after the other. If I have a third one, that is going to be next info. But I mean, this is not the way we do it, but it just gives you the standard. There's a beginning how we deal with that.
So to remove line 30.
Line 30?
Yeah.
Yes.
Will print 10.
Okay, that's a good question. If I remove this thing, what should happen? If I remove this thing, for example, I remove this over here, and I'm going to display head.next.info. What am I going to see? I'm sorry? Null? Right? Null? Because there's nothing there. No. No. It's not 0. Now let's have a look. If I don't do this, what's inside of head.next? There's not nothing. It's almost nothing, but it's null. Because head is n1, right? What's inside of next of n1 is null. So if I do head.next, this is going to be null. And can a null have an info? How can null have an info? So this is going to give you a runtime error. Exception. Null pointer exception. You're trying to use something that is null and expect it to be an object, but it's not an object because it has not been either instantiated like this or associated to it. So if I remove this, the next stays as null, so I cannot have the info of something that is null. But if I change the next to be an object that has an info and has a next, then this is not going to be a null pointer. Is it clear for you, this part over here? Yes. Line 22? Yes. I cannot hear you. Can you raise your voice? n1.next equal n2, but n2 at this time is not declared. So at this time n2 doesn't exist yet, because n2 will be declared only after. If you declare it before, then yes. So now this node here is a simplified version of the one that is a generic one. Now if I'd like to make it generic, I just need to put this T. Now this becomes generic, which means now if instead of me doing just SSL node, I can just specify what's the data type of this SSL node. Oops. Now I need to do something like this, right? Or like this? Well, let's just keep this discussion to another time, because actually seeing that it tells you that this is redundant, you can just do this. That's fine, because you defined it here, you just use it here anyways. So now I'm just specifying that this is an integer, and then you remember that with the generics I cannot use primitive data types, so I cannot put int here, because primitive data types cannot be used in the generics. But there's this integer, which is some kind of a wrapper class for the int. It's a class data type for the int primitive data type. Okay, now let's just have a look now at the code. So this is something like I wanted to just to show you the basics. Now this is how this class normally, when we prepare it, we need to add some couple of things. So this is the node, the information, and this is the next node, which is the same data type basically. I forgot to make a change, because when I change it here, this should be also with the same t. So if, yeah. But anyways, now this is a constructor that if you call it, it's just going to put null null, right? This null null. What does this null, this means again? Exactly. This is going to call another constructor that takes 2 arguments. Is there another one? Yes, there is. Check this one. This constructor, same name as the class, but it has this time 2 elements. So what it does is just put this one, if you don't give any argument, it's going to call this one with null null, which means it's going to put the info to be null and the next to be null, which is basically fine. But the advantage is that if you'd like to create a new one and then add the next one to it, this is going to be very useful, because it's going to allow you to create and add a new node very quickly. And let me show you how this might work. Yes.
We'll put 8 and 1.
8. This is not 1. This is not an int. This is another node.
I mean this null null. We'll put this 8 and null and 2.
No, this null null cannot put 8. How where the 8 comes from? Now let me show you. Hold on. Now I'd like to insert this constructor. Let me just insert a constructor which will initialize the 2 of these, the info and the next. Okay. Alhamdulillah. So now if I use this constructor, now I have a constructor in this class. If I'd like to use it, now there's no default one. The default one doesn't work anymore. Why? Because now I have defined one. What I'm going to do, let me just define another constructor that takes nothing, and this constructor is going to call the one with the 2, but let's put these 2 nulls, and this is what basically I just copied the same thing. So I'm calling this one with null null. Now this one is going to work the same way it used to work, but with this new constructor that I just created, I will do something more. Let's say, for example, now instead of me doing this, I can put 10 and null here. So I don't have to do it here. I just put it here. Right? Same thing for this one. I can put 8 and then null. And I don't need to do this now because of this new constructor that I just created. But the advantage of this, I can also, for example, once I have this n1, I can do something like this. Hold on, I can create n2 before, and then put n2 to be the next one of n1. So this is n1, n1 has 10, and the next one after n1 is n2 that has 8. And that's the advantage of this second constructor that I just created now.
But n2 should be made it before,
Yes,
or we will not understand it.
exactly. But what we can do, for example, this gives you something. For example, now if you'd like to get to install a new one, let's say after the 8, let's say in that example, the 50 comes after the 8. Let's say I'm going to add the 50. I can do something like this: new SLL node to be an integer again. And in that one, I can put this 50, and after that it's null. Now this is a new object. This new object, I don't need to name it n3. I just create it and put it as a parameter. So I don't care about the name because I can still access it from this n2 dot next. And that's the thing. I can also, using this thing, put it here. I'm just showing you this is not something that is really useful, but it's possible. But let's not get too fancy now, because the headache starts to fall in, to kicks in. Yeah.
We don't want to put everything in one line.
Exactly, but this is not the way. We're not going to be putting everything in one line. We need to create now a class that will help us to add things in it. So now this node is not enough. Actually, we need something else that will allow us to add and manage the list. So that's why when we're going to be creating this, we need something that is going to help us manage, and this is something like this. We need a class like this, singly linked list. In this singly linked list, it will have two nodes that are special nodes. The one that is the head, and also the tail, because we'd like to remember which one is the last and which one is the first. And then there's a lot of methods that you're going to see. I can add to the head, add to the tail, and there's a lot of different code that, as you can see, it's a lot of fun. I know you're going to enjoy it. But we will just play with that later. But you see that it needs more into the management. That's what I'm trying to tell you about this whole idea. We're going to see this, inshallah. We're going to play with it. And if you'd like, we can try now to have some kind of design of this class. Now, first of all, now if I'd like to use this class, you see this class here? This SSL node, it's better to design it and declare it as some kind of an inner class. You remember the talk about inner classes? Java 2? Inner class, a class within a class. The advantage of that is, you know what it is? The class is not, well, it's self-dependent. Okay. So it doesn't rely on anything outside of the class. And the main thing that is interesting for us is that even if these are private, if this is inside, I can have access to the private members of the inner class, and which makes it more what we should do, because every attribute of a class should be, every instance variable should be private, and then we can have access to it. I made it public, or I made it actually not public. Because I did not put anything, it was, what's the name of the access, package access, exactly. So it was available to the package. No, I don't want to make it available to the package. I will make it only available to this class and the class that owns it. So how to do that? Well, let's create a new. I'm going to call it a class called singly linked list, and let's not be singly linked list. Now this singly linked list class, singly linked list, will have this class inside of it, and I'm going to make it private, actually, not public. And so this is a private class inside of a class. And then I'm going to be able to use whatever I need to use later on. So now in this, I will need to have, or it was meant protected. Why protected? What's the difference between protected again? You remember?
Outside the bucket, if there is a class inheritance, you can.
It's like package plus inheritance. So if it's something is within the package, it can has access to it. If it something is now, just to make this singly linked list to be also generic, we can just make it like this. Is it okay? Are you comfortable with the generics, or should we roll back to the non-generic one? Let's not make it generic. I feel like the generic is going to make you dizzy a little bit. So for now, this t for me just an int, and then I'm going to fix that later. So let's just make it for an int, and then we can generalize that to be a t whatever. Now, as you can see, this is a problem because exactly. So what should we do? 0 or -1, whatever. 0. Let's put 0. Okay, so now this class is the node that takes an int, and now I have the head and tail. Basically, why the head and tail? Because I would like to be able to add to the head or add to the tail, and it's quite easy if I know where the tail is, so I can add to it. If I don't have the tail, if I don't have this, it's going to be hard for me to know which one is the last one, because I have to go to the next, and look until I find which one is the last one. So now this head here, if I'd like to allow someone to use this class, now this node, I don't need it anymore. I'm just going to delete it. Delete SSL single linked list node. And you know what? I don't like this because I'm just going to make it easier on me. I'm going to only call it node. That is much simpler to me. It's a node, and then we know this is single linked list. Why? Because there's another type of node that is doubly linked list. That's why they make the distinction, but I don't care now. For now, our node is like what we just did. It's much easier for us to, also it's easy to read. Now, once I have this class and everything, I just go down and I would like to have a method called add to head. Now, if you give me a node, I would like to add this node to the head. Now, if I'd like to add the node to the head, that means I'm adding in the beginning, not the end. And I can have also this, and I can have also something that's going to be add to the tail. Now, to start, I'm just going to use only the head. I just need the head that I need to work with. Now, if I add to the head, what should happen? If I add to the tail, what should happen? This is what I'd like you to think about for now. Let's just work on this add to head, add to tail, and see what it's going to be doing. Let's use what we used to do, add to the tail. Now, I'm not going to use this anymore. So I'm going to declare singly linked list. This is my list, new singly list. Now this list here that I'm going to add to, let's say we used to put something to the tail, right? Add something to the tail. But what am I adding? Am I adding a node? Well, yes, I add a node, but for me, I don't need to care about what's the next. I just would like to give the information, and then this single linked list should deal with the next. I don't need to deal with it from outside of the class. So what I'm going to do, so add this information to the head, or add this information to the tail. So what I'd like to do something like this. Add, for example, 10, and then I'd like to call it again with add 8, and it should add 8 after the 10, and then the same way that we just did like earlier. So how to make this work now, and then this is what I'd like to focus on. So I'd like to add to the tail, because this is what we've been using before. We've been adding to the tail here, right? Every time I was adding something, I added to the tail, to the last one. Add to the head means if I add this to the head, that means this 8 should become the first one. Add to the tail means it will become the last one. The last one that was added becomes the last. So that's what I'd like to do. So what happens when I'm adding to the tail? When I add to the tail, the first thing that I do, I create a new node, right? With this information that was given to me, but I don't have a constructor that takes only one. I always have a constructor that takes 2. Now, if I'd like to use this, I need to have 1 and null. But you know what? I can create this other constructor that is going to take, maybe copy this one, it's much easier. If you give me only 1, I just would like to call this one, but this time instead of 0, it's the information that was given to me, and the next is null. So if you do something like this, if you use this constructor, you give me only the information, I'm going to make the next to be null. Is that okay? So let's close this. Now, if I use this one, I'm creating a node with this info, which means I just, hold on, let me go back to the this, click erase everything. I just did this, sorry, this, because this is the representation of the null. So by doing this, and assuming that this is my first number that I'm calling, the information is 10, I just created this. Now I should do this kind of link. So this is my head, and I should put the head to be this new node that I just created. So this head is going to be this new node that I created. It's not going to work all the time, but the first time is going to work. The first time, when I have nothing in the head, this is what should happen. But if the second time I cannot do the same thing, but let's just make sure it works now for now. Now the first time I create a node and add it to the head. Let's just, after doing this, I just would like to do something now. List dot. Oh, you know what? I can do something nice. I can do something like this that displays the list. So it will tell me what's inside of the list. So let's have a toString that will do that. I'm going to insert a toString that is just going to display to me what's inside of. So the toString, what to display? No, just nothing, because I would like to display something which is going to be just like this. The head, or maybe the list is, and I add to the list head.info. Head.info, right? Now if I run this thing, the list is 10. I just did this. I know it's not going to work in all cases, but I'm building something incrementally, so I don't care about other cases. What other cases? For example, what happens if I just do this? There's no info. The head is null, because when I start here, do I have any constructor here in this single linked list? No. This is a class data type, which means the default constructor that is going to be given to me by Java is going to put null here. And this, if this is null, you cannot have info from a null. So I'm going to have a runtime error telling me null pointer. Which one? This one. Because when I create this info, hold on. But I would like to know which one. Yeah, from here. So this line here, this is the line that created the problem, because when I try to go back into the toString, it ended up having this head is null. How can you have something from it? But I don't care about that. So I'm just showing you the piece of code that works just for the time that I have reached, for the step that I have reached. So if I just do something like this, this is going to work. Now what I would like to do, I would like to add to the tail again the 8, and then I would like to display. So after, now if I did this and I displayed the list, I was able to see that it worked. Now what happened if I add another information, knowing that I had something before? Now this code is not going to work for me. This add to the tail is not going to work, because what is going to happen if I just add this 8? It's just going to throw away the 10. So now if I'm here, I cannot just take this head and put it in the new one that I created. I only can do that if it's the first one. But if it's the second one, once I created this, now it's the next one that needs to be put there. So what should I do now? It's not head that is going to be node, but head.next that is going to be node. So now I have two cases. If it's the first time and if it's not the first time. Now if it's the first time, how can I know if it's the first time? Well, I need to put some kind of condition now, if else thing. If it's the first time, do this. if it's not the first time, well, do something else.
If it equal null,
If exactly the head is equal to null, that means this is the first time. And you know what? I'm not going to rely on Java's initialization. I'm going to have the constructor myself and make sure that I personally put this to be null. And make sure it's null. I don't rely on Java initializing for me. Put it yourself. It's much clearer this way. And let's just put this after the class, the inner class head. So now if this is null, just add it to the head. But if it's not, now what should I do? Head.next. Basically, I should always create a node. I should always do this. But then this is what I need to do if it's node. But then this is not going to work for all the elements. It's just for the first one. Well, after knowing that there's another one. But if it's a third one, I might have a problem. I will have a problem. But anyways, I'm just trying to build this incrementally how to solve this thing. There's different way. We're getting closer to the tail that I removed. Now the tail is going to be much helpful. And I'm just going to show you now. Now, once we do this, now if I run this 8, and I'm going to show this, if I run it, it's just going to show the 10. But where's the 8? Well, because my toString here, unfortunately, I'm not going to go to the toString. We can go it from here. The toString only displays the info. Now, because I know I have 2, what I'm going to do, I'm going to put a space and I put the head dot next dot info, just to make sure it works. Of course, this is not the final implementation. I'm just trying to show you, like step by step, that it's still working. Now, if I run this thing, I'm going to see this is 10 and 8. But you get the point. I can do something, I have to do something here. And now let's just have a look at the code, because there's no need to have a look at it small. Now, if I'd like to have a third one, that's why now this is kind of interesting to have, for example, add to the tail. This is add to the tail that we were working on. Now, this add to the tail, we check if it's empty or not. If it's empty, it's going to add it to the tail. But if it's not empty, if it's not empty, add it to the tail. But if it is empty, that means this is the first time. This is what should happen. Now, this tail here is, maybe I jumped because they're using the tail already. I just would like to go back to my easier version and start using the tail, because the tail is going to help me when I have more than these two things. Now, the head and tail are going to be allowing me, because every time I add to the last, it's much easier to know which one is the last and work with it than to start from next until finding which one is the last one. So that's why it's much useful to have the tail now. Now, if I have the tail, okay, this class, I'm going to initialize it same way. So the head and tail, both of them are going to be null. And if I had this, now, if the head is null and the tail is null, that means this is the first time. We just add it to the head. And you know what? The head also is the tail, is the same thing. We're at the same place. Okay, now it becomes confusing, so I'd like to go back to this drawing here. And in this drawing, unfortunately, we don't have the head and tail. Let me see if I have. Yes, we do. Now we have this head and tail. Maybe, but it doesn't show up in the way that I like. So let me just go back here, and I'm going to represent the head and the tail from here. Okay, erase. Now this is my head, and I'm going to add a new one that is going to be my tail. So the tail is going to be now, once I create a first time and I add this to the head, the tail is, for the first element, the head is the tail. That's the same place. There's only one element, so it's the same place. So both, now the first time both are null, but if I add one element, the head and the tail are the same. There's only one. Now if I have two, now this is going to be the tail and this is going to be the head. So if I add another one of this, if this is empty, now this is the first time, there's nothing. The head and tail is going to be my node. But if it's not, what should happen? If it's not, that means should I change the head? Does the head change? The head is still pointing to the first one, so I don't need to change the head. So the tail is going to be my new node. But there's something. Now, how can I link this new node to the one that was before? So this new node that was, now I added this new node, see? This is what I did. This here is my new node, this 8. I'm not in this case where the head is null and the tail is null, so I'm going to go to the else. What is going to happen is that this tail is going to be here. The tail is going to be the node. Now I need to put this link here. So head.next is going to be the node. Or tail, it doesn't matter because at this time it's the same. But this is not the best way. Why? Because what if now I have the third one? Now if I have the third one, like this one over here, now this is my head. Sorry, let me just cancel. This is my head and this is my tail. If I use head.next, I'm going to put this here. That's not what I want to do. Now hold on, let me just show you before I do this. Now if I'm in this case, if this is the head, where the tail would be? The old tail would be here. So basically when I'm creating this new object, what I should do, this should be the tail. Is it? No, because I'm not going to point here. Actually, the opposite should be. The next one should be the tail. So the tail.next should be this new element. So basically what I mean here is the tail.next should be the element. So now, but before doing this, this should be done before. The first thing that I should do, this one, tail.next, make it this new element, because my tail was here at the first. Then I need to change the tail to not be here anymore, but to be this one. And this way is going to work very easily. So the tail.next is going to be mine. I'm changing the node of the tail.next to say that the tail.next is the new one, and then the tail is the last one. It's going to be changed. Now the advantage of doing that is that I'm going to be able to add whatever I add, I'm going to add to the last, and this is going to be working. Let me just go back again and make sure that, just to make sure to understand what I did here. Imagine I start here. Let's clear everything. I have the head and the tail. So this is my head, this is my head, and this is my tail. The first time both of them are null. So when I created the add node with this 10, so I create a new node that's going to make 10 and then null, like this. This is my node n. And what I'm going to do, I'm going to check, is the head is null and the tail is null? Yes. The first time is going to be null. So I'm going to say yes. What I'm going to happen, this node and tail are going to be pointing to the same place. This and this points here. Now I'm going to create a new one, like this new thing here. Now after creating a new one, this is my head and this is my tail again, and both of them, this is where they are. They all point to the same place. Now this is not true anymore, so I'm going to be here. Now tail.next, what is tail.next? This is tail dot next. This is tail dot next. I'm going to put something in it. What is it? The node, this new thing, which means I'm putting this link here that points me to the node. And then this tail now is going to be the node, which means I'm moving this here. So after doing this to be the link, I'm moving this here to be the tail, not to be this one, but to be this new node that I just added. And this way I'm maintaining the tail and head all the time. So what happens if I add the third one? Now this is my head, and this is my tail. Let's see what happens. I'm going to be here. Tail.next is going to be my new node. Tail.next, this is tail.next, is going to be my new node. So I'm putting the link, and then the tail is going to be this new node. So this link here, the tail, is going to be this node. And this is how I move from one to one. Okay, I just intentionally spent some time, even though I'm busy. I wanted to get to let you go earlier, as I said, but I wanted to give you an idea about the level of complication. Now you see, I spent some time to build this single link class step by step with you. We're not going to be doing that all the time, because I see how much time it took just to explain this. We just have not even used this version when we use this generic one, and still there's a lot of things we haven't spoken about. But let's just well, this is anyways. This is just the add to the tail, which is basically was something like this that we did. Now we need to talk about add to the head, and also about is empty. Well, basically delete from the head, delete from the tail, and if you'd like to delete an element space, just try to find it and then delete it. Display them all, how to display all the elements, and to see if one element is in the list. So as you can see, I'm going to give you this file, but you have to understand it. I think now you get what I said, that this course is not easy. Actually, it requires a lot of time. If you expect to just have a look at it and then it's going to be fine and hoping for the best, that's not going to be the case. You have to spend some time trying to have a look at these. Why is this line doing? And you can see it becomes a little bit more complicated with the generics, because the syntax becomes not that clear. But my advice to you, if you have this generic version that is not really easy for you to follow, just remove these generics and then work with the specific data type. And then later on, when you get it, you can generalize much easily. Now I think you had a better idea what kind of processing we're dealing with. So the advantage is that you can plug it quite easily, but to set it up, it requires a lot of effort. So I'm going to stop here, because I don't want to knock you out from the first day. But what we're going to be doing next class, inshallah, I want you to have a look at this. I'm going to put the slides and the lab, because the lab you have also the files that you can for these things, for the code of these single link lists. And then I would like you to have a look at it and try to test it, play with it, try to add an element, remove an element, and see how it works, and make sure that you understand the details of it. Or maybe change it from a generic to a non-generic version so you can see how it works, and then you can experiment with it. But you can see that it requires a lot of time to make sure to understand all these specifics of the single linked list implementation. So we're going to make another video, inshallah, later on for how to work with those, and especially in the lab part of that.